In the Sequoia introduction video, we converted an E57 file to the SPRT file format of Sequoia, and then we meshed that data. However, in many cases, the source data might not be provided in a convenient file format like the E57, which contains metadata describing the channel mapping, unit scale, and so on. We might have just a text file containing columns of values, like an XYZ file. In this file, we have a position channel that was implicitly loaded from the first 3 columns, and 4 additional columns which most probably contain the RGB and the intensity of the scanner. But this information is not provided by the file itself, and we would have to provide this mapping manually. In addition, we can see that the existing SPRT cache that is in the same folder doesn't match the XYZ source file, and if we take a look at the log as suggested by the warning there, we will find eventually a line that says that the cache was created from the E57 file and not from the XYZ. So we would have to recreate the SPRT to match this source file. Before we do this, we would have to perform some precision analysis in order to define which storage mode we would have to use, single plus offset, or double, in order to retain the desired precision. If we select any of these channels, and we can enable the auto update to refresh the viewport whenever we pick one of those channels, we'll see that this is most probably the red, this is the green, this is the blue, and this is the intensity of the scanner. We can go back to user color, and we'll have to press the Run Precision Analysis button in order to calculate the bounding box and the magnitude and spread in order to compare to the desired precision. We could switch the point loader to use the SPRT file created from the E57, since the data in the XYZ and the E57 happens to be identical in this case, but in some cases that might not be true. So if I check the load SPRT cache, the actual data from the SPRT file saved from the E57 would be loaded, even though the two are considered to be mismatching. If I disable this option, I can run now the precision. This will read through the text file and collect information about the minimum and maximum positions. That means the minimum and maximum of the bounding box of the point data, and how far away from the origin it is. And based on this information, it automatically determines that single storage mode would be okay. Now I can hit the Rebuild SPRT cache button, and Import Text Point File dialog opens, which lets me peek into the content of the first n rows. For example, I can see the first 10 rows here, in order to determine if the mapping that was proposed, first 3 columns to be the X, Y, and Z position, and then the rest, as we assumed, would be red, green, and blue. We have to determine if this is plausible. We'll select the intensity as the last channel. The length unit is meters, and we'll remap any colors that might not be in the desired color range. For example, if the colors are in 0 to 55 range, we can bring them into the 0 to 1 range. If I press now the OK button, this XYZ file will be read. First, a decision is made whether to convert it in core, that means load it in memory and save directly to disk, or out of core, that means saving some of the data in a temporal disk file for dealing with very large source files that cannot fit in memory. In this case, it's performing in-core conversion, and now we have an SPRT which is made from the XYZ file, and now the cache is up to date, and it contains pretty much the same points with the same mapping that we had from the E57 file.